In this video, I will talk about probability distributions. We will learn how to distinguish between discrete random variables and continuous random variables, how to construct a discrete probability distribution and its graph, and how to determine if a distribution is a probability distribution. We will also learn how to calculate the mean, variance, and standard deviation of a discrete probability distribution. And lastly, we will also calculate the expected value. So a random variable represents a numerical value associated with each outcome of a probability distribution. It's denoted by the letter X. So examples would be the number of sales calls a salesperson makes in one day, hours spent on sales calls in one day. So those are all represented by the letter X. A discrete random variable has a finite or a countable number of possibilities. So for example, X is the number of sales calls a salesperson makes. That would be discrete because that's something that you can count. Either a person made one call, two calls, three calls, and so on. A continuous random variable has an uncountable number of possible outcomes and is represented by an interval on a number line. For example, the hours spent on sales calls in one day. So you may not have spent 3 hours making sales calls. You may have spent 3 hours, 26 minutes, 3 seconds, so on. So that's something that's continuous. Time is considered a continuous variable. So we're going to determine whether or not these random variables is discrete or continuous. So the first one says let X represent the number of Fortune 500 companies that lost money in the previous year. So this is something that you can count. You can count the number of companies. It's not going to be a continuous number. So this will be considered discrete. The next one is the volume of gasoline in a 21-gallon tank. So anything that can be measured is usually considered continuous. Okay, so it can take on any volume between 0 gallons and 21 gallons. It's not going to be, it may not be exact. It might be 5 gallons. I don't know how those measurements go, but it can have some extra decimals after it, after the 5 gallons. So with discrete probabilities, your probabilities have to fall in between 0 and 1. Okay, so your probabilities cannot be negative and your probabilities cannot be over 1. And when you add up all the probabilities in the probability distribution, they have to equal 1. So they have to satisfy these two conditions. So let's talk about how to construct a probability distribution. We'll let X represent the discrete random variable with possible outcomes x1, x2, all the way to xn. We're going to make a frequency distribution for the possible outcomes, and then we're going to find the sum of the frequencies. We're going to find the probability of each possible outcome by dividing its frequency by the sum of the frequencies. And then you're going to check. You're going to see whether or not each probability falls in between 0 and 1. And you're going to add up the probabilities to see if they add up to 1. So in this example, an industrial psychologist administered a personality inventory test for passive-aggressive traits to 150 employees. Each individual was given a whole number score from 1 to 5, where 1 is extremely passive and 5 is extremely aggressive. A score of 3 indicated neither trait. The results are shown in this table here. And we're going to construct a probability distribution for the random variable X, and then we're going to graph it using a histogram. So in this one, they told you they gave this test to 150 employees. So when you add up this frequency column, it should add up to 150. So if you add this up, this is 150. So when you read this table, 24 employees got a score of 1, 33 got a score of 2, all the way down, 21 got a score of 5. So to construct the probability distribution, you're going to take each one of those frequencies and divide it by 150. So the first one was a score of 1. It was a frequency of 24. We're going to take 24 and divide it by 150, and that's how we get 0.16. It was 33 people who got a score of 2. We're going to take 33 and divide it by 150. And we do this for each frequency. We divide by 150. So let's check to see if this is a discrete probability distribution. As you can see, each one of these probabilities fall between 0 and 1. And when we add up these probabilities, they add up to 1. So we're in good shape. Now, sometimes if you have, when you divide, you may end up rounding. So you may not get exactly 1 when you add up the probabilities. You might get 0.999, or you might be slightly over. You might get 1.01. And that's due to rounding error, and that's not uncommon because sometimes when you divide, you round at the same time, depending on what the fraction is. Okay, so we can go ahead and draw this in a histogram. This is going to be a probability. This is a relative frequency histogram. So if you look at the score, we have a score of 1, and we're going to draw the bar up to 0.16. For 2, we draw it up to 0.22, and so on. For 5, we draw it up to 0.14. And as you can see, this histogram looks bell-shaped, so this is symmetric. Okay. Alright, so let's look at some other probability distributions, and we're going to decide whether or not they're legit. So in this one, this is the number of days of rain, 0 days, 1 day, 2 days, 3 days, and the probability, corresponding probabilities. So let's see, as you can tell, each one of these probabilities fall in between 0 and 1, 0.216, 0.432, 0.288, and 0.064. So that's good. They all fall in between 0 and 1. And when we add these up, we get 1. So this is a legit probability distribution. And this next one, it doesn't have a scenario with it, but it says 5, 6, 7, 8. And this might still be a range, the rain one, but it's the number of days are now 5, 6, 7, 8. So we got the corresponding probabilities. As you can see, the probabilities still fall between 0 and 1. But when we add up these probabilities, we get 1.07, and that's greater than 1. So this is not considered a probability distribution. This next one, our x is 1, 2, 3, 4, and then we got these fractions. Once again, your probabilities have to fall between 0 and 1. So the probability 1/2 and 1/4, that's good because they fall in between 0 and 1. However, 5/4 is really 1 and 1/4, so that's greater than 1. And then -1 is less than 0, so these two won't work. Okay, so you don't even have to worry about trying to see if they add up to 1. They may add up to 1, that's fine, but right now these two would be an issue, and this would not be a legit probability distribution. So with a probability distribution, you can calculate the mean, the standard deviation, and the variance. And I'm going to show you how to do this in StatCrunch and one of my Excel templates, and I'm also going to show you how to do it by hand. So for this first one, this is for the mean, and we're going to go back to our test, the passive aggressive test. So in order to calculate the mean, you're going to take x and multiply it by its corresponding probability. Once you get all those, you're going to add them up, and that will be your mean. So if we go back to this example, what you're going to do is you're going to take 1 times 0.16, you get 0.16. Then you're going to take 2 times 0.22. This is multiplication. This is 0.44. Then you take 3 times 0.28. You get 0.84. 4 times 0.2. You get 0.8. And then 5 times 0.14. You should get 0.7. I believe. Let me double check that. Yes, 0.7. So when you add these up, you should get 2.94. So the mean score on this test that they gave is 2.94. Okay, so that's how you do it by hand. You can calculate the variance by hand as well. And it's kind of long, so I don't suggest that you do this by hand. But if you're the type of person that likes working by hand, that's fine. What you're going to have to do is you're going to subtract the mean off from each one of your x values. Then you're going to square that answer, and then you're going to multiply it by its corresponding probability. That will give you your variance. Once you get the variance, you take the square root and you get the standard deviation. So if we go back to this example, the score with the probability. Like I said, we already calculated the mean. We said it was 2.94. We're going to subtract the mean off from each one of the x values. Okay? And now what you're going to do is you're going to take your the answer, and you're going to square it. And then you're going to multiply it by its corresponding probability. Okay, so I'll do it for each one. And when I did this, I did not round. For example, that negative 1.94 squared, I used the whole answer. And then I multiplied it by 0.16. People tend to round, but if you just do it all at once in the calculator, that's fine. And then when I multiplied out the first one, I got 0.602176. When I multiplied the second one out, I got 0.194392. I'm going to square this one, and I'm going to multiply it by 0.28. And when I did that, I got 0.001008. And the reason why it's best to not round when you're doing in the course of the calculation is because your final answer will be off. So that's why I don't round until the very end. So here I got 0.22472, and then this last one, 2.06 squared times 0.14, I got 0.594104. Can't read my writing. Okay, so when I added these up, I got this answer here, 1.6164. So that's my variance. In order to figure out the standard deviation, I took the square root of that, and I got 1.3. Okay. All right, so what does this mean? Most of the data values differ from the mean by no more than 1.3. So I'll go ahead and show you how to do this in StatCrunch. I already have my numbers in here. I have my x values and the corresponding probabilities. You're going to go to Stat, Calculator, and then you're going to come down here to Custom. Your values are your x values, and the weights are considered your probability. So you want P of x. You hit Compute, and it'll give you this graph. It's not a histogram. Kind of looks like a histogram. If you look at it, it's a symmetric shape, and that's what we said it was when we did the histogram. So this is just like a little bar, a little stick graph, I call it. So as you can see, we get a mean of 2.94, and that's what we did when we calculated it by hand. And we get a standard deviation of 1.27. Well, we rounded it to 1.3. So this will give you the answers. Now, if they ask you what the variance is, so let's say you get a problem and you were able to calculate the mean and the standard deviation, but your homework assignment also asks you for your variance. What you can do is just take the standard deviation and square it, and then you'll get your variance. So this won't calculate the variance, but you can just use the standard deviation to get the variance. Now in my Excel template, I actually calculate the variance for you as well as the standard deviation. So I'm going to go ahead and punch these numbers in. Oops, this is 5. So I have my X column, and then I have my probability column. And you go ahead and type this. You only have to fill in the color part, the pinkish part. And once you start filling this in, numbers on the side over to the right will start to populate. So you'll see all this, and this is just set up so it can calculate the mean and variance and standard deviation for you. So as you can see, if you look down here, I have sum and it's equal to 1. So that's a good thing. Our probability is equal to 1. And as you can see, once again, all the probabilities fall between 0 and 1. If you scroll down here, it calculated the mean for you. It's 2.94. That's this first one. The variance, which is 1.6164. And it also did the standard deviation for you. Okay. All right. Let's talk about expected value. Let's see. At a raffle, 1,500 tickets are sold at $2 each for four prizes of $500, $250, $150, and $75. You buy one ticket, find the expected value, and interpret its meaning. So when you pay out money to buy a ticket and you win, you don't actually win that amount. You have to consider the amount that you use to purchase the ticket. So if you purchased the ticket and you won $500, you got to consider that $2 you put in. So your gain is actually $498. If you win 250, your gain is 248. If you win 150, your gain is 148, and if you win the $75, your gain is actually $73. So if you do not win a prize, you have lost your $2. So we can make this into a probability distribution. The chances of you winning that $500 ticket is 1 out of 1,500 because it's 1,500 tickets that they sold. The same for the 250 ticket, $250 prize. The chance of you winning that is 1 out of 1,500. The same for the $150 and the same for the $75. But we're looking at the gains. The chances that you lose would be 1,496. I got that because it's 4 tickets in there that are winners and the rest are losers. So that would be, if you took 4, subtracted it from 1,500, you have 1,496 tickets that are losers. So you can go ahead and calculate the mean. The mean is the same as the expected value. Okay, it's denoted E of X. So you can take 498 times 1 over 1,500 plus 248 times 1 over 1,500 and so on. And as you can see, you get a negative answer. You get negative $1.35. So you can expect to lose an average of $1.35 for each ticket you buy. Now, I don't know how to do this in StatCrunch, and the reason why I say that is because your probabilities are fractions. So you can likely do it in StatCrunch, but you're going to have to divide out that fraction, that 1 over 1,500, as well as that 1,496 divided by 1,500. And you have to use the decimal part for your probabilities. And I think the decimals are long, so I wouldn't try to attempt to do that in StatCrunch. You can just likely just do it by hand. If you do it in my Excel, what you can do, and I'll go ahead and type in the gains. So what I did was, this is -2. For my probabilities, Excel will calculate it will divide the fractions out for you. So what I did was I put an equal sign and I put 1 over 1,500. And as you can see, you get that long decimal. So when you put the equal sign in front of it, it knows to calculate it out. So 1 over 1,500, I'll do it again. And I'll do it one more time. And then for the last one with the negative, it was 1,496. I put an equal sign in front of that and then divided by 1,500. Okay, so like I said, you can do it by hand if you want to, or you can use the long decimal and put it into StatCrunch and have StatCrunch do it for you. But as you can see, it calculated it for me, and I have the expected value here. And like I said, the expected value is the same as the mean, and I got a negative $1.35.